right, hi there. This is video number 1 for pre-calculus. And this is the first time that you're actually taking notes. So I just want to remind you that you had 2 options. You have a loose leaf paper in a 3-ring binder, or you've got a spiral notebook. And you're going to be putting your chapter and sections down in the bottom right corner if you're on the left hand, if you're on a front page, essentially. So this is chapter 4, section 1. I know it's a little weird, but I'm actually matching the chapter and sections with the textbook in case I give you the yellow book that we have for this class. And then we're going to be using something called Varsity Learning, and Varsity will also have corresponding chapter and section numbers. And then make sure in the upper left-hand corner, you're putting your video number. We'll reference those. And then you're also putting your chapter and section numbers on the upper right-hand side of the page. So we have chapter 4, section 1, and then the topic in the middle underneath of that. So this is radian and degree measure. And the first 3 chapters that we're going to do are all about trigonometry. So you may have had some trig when you did geometry. Remember sine, cosine, tangent? That was right triangle trig. We're going to do a very tiny little bit of that. It's maybe our 4th section or so. The rest of this is all going to be a little bit weird. So compared to what you may have done before. But I don't know. I love trig. I think it's one of my most favorite topics. And essentially, if we're doing 3 chapters of it, it'll probably take us almost through the first semester. So it'll probably take us through our Christmas break. And I don't know if you know this, but trigonometry, it's a Greek origin. And so we're going to be using a lot of angle measures in the Greek alphabet. And it literally means measurement of angles. All right, so a couple things that you need to know. There are 2 ways to measure angles. One is the traditional way with degrees, which actually gets more specific. So a degree can be broken down into minutes, and minutes can be broken down into seconds. And this is used in navigation. So you may have just seen degrees before, but we will be talking about degrees, minutes, and seconds. And then 2, another way to measure an angle is with something called radians. And we're going to introduce those here in this first section of this chapter. Another couple things that you need to know about angles is that an angle is made up of an initial side and a terminal side. And often we're going to be drawing these on a coordinate plane where the initial side is always the positive x-axis. So the initial side is the positive x-axis. And then the terminal side is what actually makes up that angle. So the angle might be here. That might be some angle alpha. The angle could be the outside of the angle. That could be some angle beta. So here's some Greek letters for you that you're going to see commonly. That looks like a little fish. That's alpha. A weird capital B with a tail is beta. You're definitely going to see one called theta. That looks like a circle with a little line through it. There's this R-type looking thing, which is gamma. And those are probably about the only 4 that I would use. There's lambda and some other ones, but they're not very commonly seen in this textbook. So these 3 will be the primary ones that we'll use, with maybe an occasional gamma if we need it, okay? So an angle is made up of an initial side. That initial side would be here, and a terminal side. Angles can be positive or negative. A positive angle is if it goes in a counterclockwise direction. So up here, that would be this guy, alpha, would be a positive angle because he would be going counterclockwise, and a negative angle always rotates in a clockwise direction. And up there, that would be angle beta, because it would start, again, it would start with this axis right here, and it would be going around this way, and that would be the clockwise direction. So beta would be negative. You'd measure from here over to here. Alpha would be positive. You'd measure from here over to here. So also recall that there are 360 degrees in a circle. So in this case, if I was to tell you up above that, let's say alpha was 135 degrees, we would know that beta would be 360. So beta would be 360 minus 135, except the answer would be negative. So this guy would be a negative 225 degrees. So if you added just the absolute values, 135 and 225, you would get 360. But because of the direction of travel, you need to apply. So that's all that this sign indicates, is direction. Okay. So recall that there's 360 degrees in a circle. Okay. Also, terminology that you may not know. Up above, if angles alpha and beta have the same initial and terminal side, initial, I spelled that wrong. Initial. Oh, good Lord. So this is a good time to talk about note taking. You guys have the ability to pause me, rewind me, take some notes, highlight, put notes on the side of your notes. If you don't know what things mean, pause, go look up some extra stuff. This is your class. You need to make the effort, if you don't understand something, to go look it up and make sure that you know what the heck is happening. Also, this year I'm going to make all my tests open note. I've always kind of used this little formula journal, which you guys could add stuff to, but this year I'm going to literally do open note. So anything that's in your notes you can utilize on a test. So the more complete and comprehensive those notes are, maybe the better off you'll be on a test. So if you need anything in there, add it. I don't care. So if angles alpha and beta have the same initial and terminal side, they are called coterminal angles. Okay, so you may be told alpha is 135 degrees, name its coterminal angle, and you would have to identify that as negative 225 degrees. Okay, so this would be a word that you would want to make sure that you know going forward. Let's see. Also be aware that if you're on a coordinate plane, These things can keep rotating, right? If you start here on the x-axis and you go around one time, that would be 360 degrees. But if you go around another time, that would be 720 degrees. And then let's say you stop here. So, and this is 45 degrees. So let's say, I don't know what's 720 and 45, 765. So you might be told that this whole entire angle is 765 degrees. And then you might be asked for an angle that's less than 360 that's exactly the same. All you have to do is take off 765, take off entire rotations. So if you take off an entire rotation, you get 405. That's still bigger than 360. So take off another 360 and you get the 45. Okay, and that's what you would want. So if you're given one big angle like that, these things can keep on going. So you can name multiple angles. Or if you're told you have an angle that's, I don't know, 170 degrees, and you're asked to name 3 other angles that are exactly the same value, you can just add 360 to that, right? 170 plus 360 is 530. So 530 would be exactly the same. I could go this way, and that would be exactly the same. So that would be, this has to be 10 in here, right? Because that's 180. So that would be a negative 190 degrees. That would be exactly the same. I could add 360 to that. 360 plus 190. That would be a negative 550 degrees. That would be exactly the same. So you see what I'm saying? Like you can just keep adding rotations and it doesn't really matter what direction you're even going in. So you need to be comfortable with that actually happening. All right. So let's talk about radians. A radian. So I'm going to give you the definition and then give you two little formulas to convert them between degrees and radians. So 1 radian is the measure of a central angle we'll call that theta, that intercepts an arc S equal in length to the radius of the circle. So here's a picture that will demonstrate that. I'll try to, if you give me a minute here, I'll try to make this as specific as possible. We'll make a circle. Okay, and then we'll make these little lines. Try to go right from the center. Okay, so those are represented by, that's a radius, that's theta in there. And then from here to here would be the arc length S, and that is equal to R, the radius. Okay, so at this point, theta equals S over R. Okay, and here are a couple of conversion. So this isn't going to make a lot of sense yet, and we'll do a lot more in the next section that's going to, I think, help you kind of visualize what these radians are. But at this point, here are a couple little formulas that you're going to need. So to convert between, oh, no, that's not the right word. To convert radians to convert degrees to radians. I had the wrong words in my notes. You're going to multiply the degrees by pi over 180. And then you have to simplify. Make sure that you simplify. And then to convert radians to degrees, you're going to multiply the radians by 180 over pi. Okay, so these are hugely important. I want a different color here. I would recommend using highlighters when you take notes, and this would definitely be highlighter worthy, right? You can just take your highlighter, highlight these suckers so that they stand out in your notes somewhere. You could use, bubbles or whatever you want to do with those things. So there's going to be a number of formulas that you're going to have for trig. I mean, it's kind of ridiculous, actually. So I would definitely recommend some formulas or some highlighters for you. Okay, so let's practice these, a couple of these. Also, just a note, you're going to be leaving, in almost every single case, you're going to be leaving your pi in your answers. Okay, so that's going to happen. So let's convert 135 degrees to radians. So what you're going to do is you're going to start with your degrees, and you're going to multiply by pi over 180. And essentially, you're going to get 135 pi over 180. And just plop your 135 over 180 into a calculator and reduce the fraction. Don't get a decimal, reduce the fraction. When you do that, it's actually 3/4. So the 135 over 180 reduces to 3/4. So this becomes 3 pi over 4. And that's your answer. Okay? Signs don't make a difference. Convert negative 270 degrees to radians. So you take the negative 270, you really don't even have to deal with that, and just put it on your answer. We're going to take 270 times pi over 180. You probably know the trick where if you have a 0 on the end of each of these, you can just slap the 0 off. So this gives me a negative 27 pi over 18. 9 goes into 27 and 18, 3 and 2. So this is negative 3 pi over 2. I also highly recommend that you get good at reducing things and cross-canceling, not cross-multiplying, cross-canceling. Comes in very handy as you move up the levels in math. All right, let's go the other way. So that was converting degrees to radians. Let's convert radians to degrees. So let's convert 9 pi over 2 to degrees. So we take 9 pi over 2 and we multiply by 180 over pi. Now when you do this, because you're going 2 degrees, your pi's should cancel out if you're doing this the right way, and they do. And then, again, I like to cross cancel. Well, 2 will go into 180 90 times. 9 times 9 is 81, so this is 810 degrees. Okay. And then if we take, let's do another one, convert 2 pi, 2 degrees. So we take 2 pi times 180 over pi. Now this guy's over 1, right? Because there's nothing there. Pi's cancel out. 2 times 180 is 360 degrees. And that's exactly what that is. So those are pretty straightforward. Okay, the next couple things we have to talk about are arc length and area of a sector. So arc length, we sort of touched on in the definition of a radian. Arc length is real straightforward. The formula is S equals R theta, where R is the radius of the circle. The only trick here is that theta must be in radians to do this. So if it's not, you have to make sure that you convert it, okay? So if you had something like, if theta equals 45 degrees and R is 12, find the arc length. Well, the first thing we have to do is convert this guy. So we're going to go 45 times pi over 180. And when you do that, I'm just going to plug 45 ABC 180 into my calculator. And I get 1/4. So this is 1, this is 4, and I get pi over 4. You might also see this, you probably won't, but you might see this written as 1/4 pi. That's weird. This is more common, just so you know. So now I have S equals R theta. Well, we know that R is 12. Theta is pi over 4. 4 goes into 12 3 times. And so this is 3 pi. And you would leave that as your answer. You're going to leave your pi in your answer. And you guys are going to be using an application called Varsity Learning. If you're new to me, it may be new to you. And you're going to be typing in answers. I've already there's a demo in Varsity Learning for you. I'm sorry, in Google Classroom for you that you should have watched and signed up for. And so to type this answer in, there is a box. You can go to a formula editor and find pi, or you can literally type in 3pi and it will turn it into 3 pi over on the side. So you'll get the hang of it pretty quickly. It's a very easy application to use. All right, so that's how you use arc length. Next, area of a sector. There's some weird wonky thing in Varsity. Ignore that. This formula is better. So area of a sector is R squared theta over 2. Okay. And just so you know, if you're, again, new to me, I make my Z's with a cross. So if you see a 2 like that, it looks kind of like a Z, it's a 2. I will put a line through my Z's and a line through my 7s, just so you know, so that you have an indication of how I'm writing things. Okay, so here is a problem. If theta equals pi over 3 and R equals 12, find the arc length. I'm sorry, the area of the sector. This one, again, be sure that theta must be in radians before beginning. And this one is, right? So we have area of a sector. R is 12. So we have 12 squared times pi over 3 all over 2. So here's how I would simplify this. I'm going to use a calculator as little as possible. So I have 144 times pi over 3 over 2. And 2 over 144 is 72 times pi over 3. That's 2 goes into here 72 times, right? Because 2 goes into 14 7 times and 2 goes into 4 2 times. That's just halfway decent math. And then 72 divided by 3, this goes in here twice, 6, 24. So this is 24 pi. That is the area of the sector. That was, again, no calculator usage, just me dividing 72 by 3. So long division comes in handy. It's faster than some of you could do that on a calculator. Get good at that. You need to use it when you take an ACT or something. Sometimes it's easier. Coffee break. What the whistle. Okay. 2 more things. We have linear and angular speed. And these are pretty straightforward. So you have linear speed is arc length over time which is s over t, and then you have angular speed. Oh Lord. Ang is central angle and that guy is theta over t. And so these are talking about, in varsity, there's some problems that say find the linear speed of a point that covers a distance t in time, blah. Let me see. In the textbook, there's a blue box at the bottom of page 263 that's got these things. It says, consider a particle moving at a constant speed along a circular arc of radius r. If s is the length of the arc traveled in time t, then the linear speed of the particle is blah. Moreover, if theta is the angle in radian measure corresponding to the arc, then the angular speed is blah. So it's just finding these 2 things. So here's an example of using each one. The first one says if s equals 20 feet and t equals 5 minutes, find linear speed. So this is going to be linear speed is s 20 over t 5, and that's going to be 4 feet per minute. Okay? So this is pretty straightforward. And then angular speed. Find the angular speed of a point P if theta equals 2 pi over 3 and t equals 3 seconds. So this guy is going to be theta, so angular speed is theta over t, which is 2 pi over 3 over 3, right? Well, this 3 is really over 1. And remember, division of fractions. A over b divided by c over d is a over b times d over c. Keep the first one, change the sign from division to multiply, and flip the second one upside down. So you turn your division into a multiplication symbol, into a multiplication problem. So this is really 2 pi over 3 divided by 3 over 1. So it's times 1/3, and I can get rid of that whole thing. And this becomes 2 pi over 9. And that's the answer to that guy. Okay? This we're going to use a ton in this room. Make sure that you're familiar with your rule of fractions and you know what's happening when you do that. I mean, you could stick this in a calculator too, but you really should know how fractions work. We do a lot of them. All right, so that's the first section. I like to be goofy a little bit, and oh gosh, let me start that over. I wrap up all of my videos by telling you toodaloo. So toodaloo. Oh, wait, hold on. Don't forget to put your 4.1 there if you're on the front of a page, here if you're on the back of the page, so that you can rapidly flip through your notebook and find what you need as we go. Okay. Also, when you do your work, excuse me, I get a tickle in my throat when I talk too much. When you do your work, your homework, classwork, whatever, show all work. Write the problem. And show your work. So when you submit it to me on Google Classroom, you get 2 grades. You're going to get a completion grade for showing your work in Google Classroom. And then in varsity, you'll get a correctness grade. And remember that you can try problems over and over and over again in varsity until you get this 100% correct, right? So this is just you turning in your work and me being able to see your work and it making sense. Now, I've been doing this a long time, guys. This is my 20th year teaching. You're submitting work to me through Google Classroom and I'm looking at it. I can tell if you are skipping steps and just giving me garbage. And I will call you out on it and I will not give you full credit. So don't be just throwing answers on the page. Actually do your work. It comes out to be better for all of us in the long run. Okay? All right, that's all I got. Toodaloo.